Okay, we have started recording. Let us start. So today what we'll discuss is, we'll be discussing what happens if you, all this while you have been seeing a single distribution, right? What is the probability of a single distribution and so on. But now in real world, do you have only one distribution coming out of a sample space? I don't think so. So if the food you eat can have an effect on your, say, a random variable of height and weight, right? Your nutrition and your food can have an effect on both of these random variables. And then these random variables can have a correlation among themselves. Correlation, I'll come to what is correlation. Say height is increasing, then your weight can also increase. This is called, say, height and weight. In some cases, one can increase, one can decrease, and so on. So there can be many statistics of two or more random variables and their combinations. So how do we study? How to study multiple random variables on the same sample space. So the idea is it's also like a random vector. So you can, so X is a random vector, then it will map an element to a, it will not, you go details of random vector, but the idea is if X is a random vector, it may map to X of omega. Can you please switch off your video, Tushar? X of omega and Y of omega, right? Good. So X of omega and Y of omega can be two values that it can take. So for example, omega can be the food, and you can output the weight and the height that you will generate from eating that food. So in a class, you can have a height and a weight distribution. So you can have points of people, say, having some height and some weight. So you have to study how the height and weight, I'm just giving one example. It can be humidity and temperature and sunshine, and many covariance, but like random vectors are everywhere. So one, if you look at a face, my face, there is a correlation that, or there are multiple random variables in this picture. So there are, say, 256 by 256 image would have 256 by 256 random variables, and we have to see the interaction of all these random variables amongst each other. Is the overall idea clear? Is the story clear? So all this while you thought that there was only one experiment, but here the same experiment can lead us to different observations. So, and that observations you can think of them as features or some different values, right? Just as the height and weight example. I hope that is clear, right? Okay.
Yes.
So let us, good. So if that is clear, so let us start with something known as, what would your joint distribution in definition look like? So what would your joint distribution in definition look like? So I have already told you that distributions can always exist, that is CDFs, but PDFs need not exist. So CDF of a joint distribution will solve few questions. It will become very clear. All the definitions, I'll be teaching you joint distributions through examples, because teaching you rigorously and with like abstractness could like throw you out. So I'll not go into abstractness. Let us take examples. First example is, what is the joint distribution of X comma Y? So what was the single variable distribution? For a single variable, we defined it as, what was the definition of the CDF?
Capital X less than small x less than equals.
Very good. That means all the events such that the inverse mapped on to this range, right? If you recall. like last day O3 had told me that meaning in terms of sets, isn't it? You had told me that it is all those events for which. So just to recall, it is all those events for which you map between minus infinity to x, right? And that's probability that you found, right? This is your sample space, if you recall. Now you tell me, you give me the definition of what will your joint distribution be from the analog of a single variable distribution. What would it be? A
Like
joint. Yeah, bolo, tell.
we can take the I'm not sure, union or intersection of those events for which this
Very good.
random variables gives those give values between infinity to x and infinity to y for x and y.
Very good. But then union will not work. Can you tell me why? Because union would mean that you only one of those events have to occur, right? So, but you want both of the events to occur in some way. You could define it anyway, but the idea is both of the events should occur, right? As Chirag is telling me, both of these events should occur. What does this mean on the set theoretic actual definition? This is the random variable. This is what will help you to do the math. But what is the probability idea? What is the actual set theoretic idea of this? As you were telling me, so there would be, what would this picture look like? Say x maps from 0 to x. This set, okay? This set maps from 0 to x. There is another set that maps from minus infinity to y. So now tell me, which would be the place whose probability you would like to find?
0 to x.
So let me draw this again. So definition in terms of random variables, you have given me, but that anybody can give me. Let me just see if I can give you the actual idea of what is this random variable in this thing mean. So let there be two boundaries, x and y, right? So y is between, y is less than y, and x is less than x, right? This is we have already seen. So what does x less than x mean? Like O3 told me last day, these are set of all those events such that x of omega less than x. Yes or no? This is what x less than x means. I am reminding it this to you every day so that you don't forget this definition, isn't it?
Yes.
So what would y less than y mean? I'll give you the Venn diagram also, but let us write the set first. It would mean the same thing, right? Y of omega less than y, right?
Yes.
So what would both of these? So when I'm writing comma in my joint events a comma b, I already redefined it when I was defining my Bayes rule, right? I could define it in terms of Bayes rule also, right? So what would in terms of Bayes rule and joint events it look like? So it would look like if both of these events have to occur. So CDF would mean both of these events have to occur. Both have to occur. So what will happen? So let us denote this as a of x and denote this as b of x, right? Which I am also representing as x inverse minus infinity to x, and I'm representing y inverse minus infinity to y. Okay, so in the Venn diagram, how will things look? So there will be a set of events which will map to minus infinity to x for the random variable x, just like the set of food that gives you more muscles, maybe more immunity and more height. Similarly, from minus infinity to y, you may have another set of events like this, right? But what is too important to you? It is both when the place where both this occurs. So this is a CDF would mean the probability of AX intersection BX, or probability of x inverse minus infinity to x Intersection. Remember, this small x and y are dummy variables. They are the values that you want to calculate your CDF for, as you were telling me. I'm just recalling all these things that we have done. And this is equivalent to saying probability x less than x, comma, y less than y. Okay, Oshmit? Okay, Brahmojit, you have a question?
No, that's okay.
Okay. I think you are, yeah. Is it okay? Any doubts? Any confusions? Is the definition of, so if you have n random variables, x1, x2, xn, and then you have dummies x1, x2, xn, what would the definition of the CDF be? x1 less than x, x2 less than x2. It would be intersection of all those events. Is it okay?
Yes, sir.
Is it okay if, okay, so I think it's okay. We'll solve questions. It will become easier. Please do the homework that has been given in the last 2 days. It's very nice homeworks are there. Please try to do those, because then you will understand. Once you start computing, you will have the hands-on trying to do the things. Until you do that, you will not be able to do it. So if you have understood, tell me how will you define a PDF? So I have told you if PDF is defined, how will you define? It's always easy to define CDFs, but PDFs we have already defined in terms of CDF. How will I translate it to multiple variables? If PDF is defined, if the derivatives exist, how will I define the small fxy of the dummies xy, the PDF? So I know f of x. This is known to me. How will I define the CDF or the density function?
Means we can do d by dx, but here we have
Very
x
good.
and y. Then
Okay.
we have to do del money do x and do
Partial,
y. Yes,
partial.
partial.
Very good. So you know, so you will do. So just to, as I told in the class, I will not be going to multivariate calculus as a topic in itself. But I'll cover them because the GATE syllabus doesn't have multivariate calculus in itself, but I'll have to cover it in able to, so that I'm able to teach you machine learning. So I'll be doing that with machine learning lectures. So there will be around 3 to 4 more math sessions, and then rest of 15 or 16 sessions would be on machine learning. And there I would include the math for multivariate calculus as and when it will be required, so that you people get interest also. Like maybe people may find, if you're not finding the beauty in these sets, then it may be a bit difficult for you to like keep the interest going. So that's why I'll be going into implementation after 3-4, after getting the basics clear. But for you to understand, please go back, do the solutions and upload them, then we'll be on the same footing. So you are right in this. So let us solve one example. But before that, if two random variables are independent, what will happen? Let us do this. If x, y are independent, what does it mean? Can anyone define what two random variables being independent means? The events x in, okay, go ahead, Promojit.
When the occurrence of one does not affect the other.
No, that is the event. That is event. But random variables are defined for many events, right? We have defined, so random variables can take all inverses would be an event, right, in the sample space. Isn't it? You're understanding, right? Is it okay, Brahmojit?
Yes, sir.
So when one does not affect the other, those events are independent. But for random variables to be independent, all events should be independent, right? All. Isn't the intuition clear? So Brahmojit told me A and B are independent if probability of A comma B or A intersection B is equal to PA comma PA into PB, as we have done before. But for random variables to be independent, all events generated by the random variables must be independent, right? It is much more strong condition. You have to understand that to be independent, all events generated by the random variable. Now you may ask, what is generated by random variable? It's nothing but x inverse minus infinity to x. Always keep this set definition in mind. Okay, that will help you. All events generated by the random variable must be independent. Okay. How do I now how do I define independence of random variables? Can you help me now? So I told all events are independent. So x inverse minus infinity to yeah, go ahead.
Disjoint. The mapping was disjoint.
Yes, for all x comma y, this should be equal to probability of x inverse minus infinity to x into probability of y inverse. And in case you are thinking, what am I writing x inverse and all? This is nothing but x less than equal to x and y less than equal to y, which is comfortable to you, I guess. Okay, so what does this mean? Fx, Fy. So this is why I'm trying to intuit is equal to. So Oshmit, now tell me, how will your CDFs look like? How will your PDFs look like? So you see, your CDFs will by definition product out, right? How will your PDFs look like? Yeah, Oshmit, tell me.
I was thinking, yes. Yeah.
So Oshmit, I think, told me the definition how to convert CDF to PDF. So I will take the derivative, right? Now tell me, what will it be? Tell me, just take the derivative, na? Derivative taking is very easy. So this is constant for y, this is constant for x. So d dx, df dx, you can just write d dy, dy. So I guess this, when you look back at this, you will feel that you have understood all concepts of. So once you have understood events generated by a random variable, you will understand everything. So all your formula, 100 formulas in the book, which is defined on joints, would no longer be required because you could use just the basics. Is this okay, Ushmit, now?
Yes, sir.
So I would take the derivative as I have defined all this while. If you don't recall, please go back and look at it. We have derived all this and I'll get product. So anytime that is independent, I will productify. It will product out. So now let us solve questions and see how to use these. And if you have understood, you will help me to solve these questions. Let us see if we can solve. So the first question is, so I have told you, so again, this will be the same integral. I had defined in terms of integral, but you can like very easily understand that the same thing as we have seen before. We went about understanding it in a different way. You can also look at the other way, PDF definition. But PDF definition does not always hold. Why, Loshmi? Can anyone tell me why it doesn't hold? PDF definition? Why does the PDF definition of density distribution always does not hold? Because the PDF may not be defined, because it's defined in terms of derivatives. If the derivative is not defined, the PDF will not be defined. Okay, so let us do this question. I have two random variables x and y, which are independently sampled between 0 and 1. I am told to find the joint distribution of xy and the joint PDF of xy. Let us find the PDF. Can anyone tell me how to go about this? So there are two independent variables, right? X and y. What are the values that x can take? as we were discussing.
0 to 1,
Yeah,
any of them values.
very good. 0 to 1.
Y is
And what
also the
values?
same. Y is
Okay.
also the same. So we plot it
Also,
on
did you
another.
understand the rest of the parts where we generated the where we showed
Yes,
independent?
yes,
Good.
yes,
So
absolutely.
now using the definition, the same definition that we have defined, let us
The joint will be
also
that.
define that. Then it should be defined for everything in this area, right? Yes or no? A point can lie anywhere. So if you do a sample, you will sample first from X, and then you'll sample from Y, and you will get X comma Y as a point. So now comes your example, which will give you the intuition of how to solve these questions. So it can lie anywhere between 0 and 1. So you agree that this is your density function. So what would be your density? Tell me. So do you agree that it will be uniform? Because it is all the products are. So what would f of x comma y be? I have already given you the hint as they are independent. So what would f of x y be?
Fx of x into fy of
Very
y.
good. Very good. If x comma y are between 0 and 1, right?
Yes.
0 otherwise. So fx comma y xy is going to be 1 in this box A. Otherwise is 0 is
Otherwise, yes.
0. So is the now just to validate our answers are correct, how will I see if the PDF is correctly, we have found the PDF correctly?
We'll integrate and see if it is 1.
Very good. So 0 to 1, 0 to 1, dx, dy, right?
Yes.
This is gonna be, in case you don't understand, stop me. Anyone who does not understand. Okay. So if you have understood, if your
Dada.
x and y, yeah, go ahead.
Yes, means till now we were plotting the graph with one side as the variable and the other side as
Correct.
the values it
Very good.
was taking.
Now you cannot plot the graph because you will have a 3D graph, right? At least for two variables.
Okay, so the one value that we are getting for fx comma y, that is on the
Yes,
z line.
Z axis, very good. If you if I'll maybe you should yes, you should, I should have give you a little bit intuition. They can be plotted as contours, like whatever these lines are. So the heights of these functions can be plotted as contours, but you can go back. I can refer to you a material. You can see MIT's video of Arthur Murdoch. If you ask, that gives you the idea of the first few videos, how to plot in 3D, right? Then you will understand. You cannot plot 3D in paper, right? You are right that it will be along the Z axis. But you have to think in terms of without thinking of the value now. You have to just think abstractly. Okay. Is the rest of the thing clear?
Yes.
Good. Now tell me, if they're independent, what would be the expected value? They are independent, so expected value would be
Multiplication e of x into
very
e
good.
of y.
So it is equivalent to doing x and y independently, right? Expected value of x would
Yes.
be just expected value of x, that is half. Expected value of y would be expected value of y. So you would have half comma half as your expected value, x comma y. So it will be a vector, not one value, okay? Because we have two variables, right? Half comma half. Is it okay?
Actually, what I need over here, if I say expected value of x comma y, means I'm not
I am
understanding
talking
that.
about the okay, go ahead. You're not
So
understanding?
expected value of x comma y should be the
So there is,
that
how can you have expected value of comma? Comma, how are you defining comma's expected value? So expected value of x is defined as, again, same thing, x into f of x.
f of x. Yes.
So x will be computed separately, y will be computed separately. So both coordinates will do the second question. It will become very crystal clear. I'm not introducing conditional expectation yet, but we'll come to it. Let us see.
Yes.
But let us do simple things first and then go to more complicated things. But I think now you have understood how the field of distributions look like. But I'll give you, see, the second question, this distribution you will do as a homework. But for this will be a homework. But now this one, I'll show you how to find distributions as well. So generally, you will not see distributions being plotted for CDFs. Let us try and do that. So now tell me, if I have this between 0 and 1, right? This is your x, this is your y. Now tell me, how will I get the distribution? So do you agree distribution has to be defined for all x, y minus infinity to infinity? Right? It cannot be only
CDF
defined.
also.
Yeah, CDF.
Oh,
How will I find CDF?
it is 0 to y
So give
integral.
me like the easiest parts. Which are the easiest parts? Can anyone tell me the easiest parts where things can never occur? So let x be less than 0 or y be less than 0. Then what would be the
Be a,
CDF?
0.
Very good. Why will it be 0? Again, now I will tell you to prove it why it is 0. So these parts are 0, right? CDF of these parts are 0. Agreed?
Yes, sir. There
And
is no area of the graph over there.
area
That's
of
why
the
0.
graph is all right, but I want to. So what is f of fx comma y? This is probability that x is less than x. Since this is independent, y is less than y. Independent. Okay? Yes or no? Any doubt? So if this is the case, what is the probability of y is, if y is less than 0? What is the probability of y less than -1? Say?
0.
Very good. So y inverse minus infinity to -1 would be just the empty set, right? So this will have probability 0. Very good. Now tell me if second case would be x comma y between 0 and 1. Both are between 0 and 1. How will I find CDF?
Means that integral of 0 to x.
Here, so yes,
And
very good. Here would be integral of
integral of
1 dx dy 0 to x and 0 to y and 0 to x, right?
0 to x. Yes.
But here it is very simple. You can just see this and write it x comma y, right? Because they are independent.
X, y.
Now tell me, now comes the more tricky part. If y greater than 1, x between 0 and 1, then what will happen? And if y between 0 and 1, so these are the cases. All the cases are being covered like this.
The that one y is greater than 1, x lie between 0 and 1, it will be only x, I guess.
Good.
Yes, x
Why?
dot 1. X dot 1.
Exactly. But why? Yeah, very good. So you are here. It is very simple to see. This is because probability of x less than x, probability y less than equal to y, and given is y is greater than 1. So in this case, this goes to 1. So this only stays to x. Similarly, y. So you have understood. Now I am seeing, see, this is when you do the examples you solve, you automatically understand what the things are. I guess you have understood, right? What are CDFs? What are expectations? What are all these things? And what is PDF relation between CDF and BDF of when there are multiple variables interacting between one another. Okay, let us do the second question and then all interactions will be clear. First, I was trying to show how to handle two variables. Now I will try to show you how to handle variables when they are interacting with one another. One is affecting the other. The very first question is saying there are two random variables such that x plus y less than equal to 1 and x greater than 0 and y greater than 0. And you're told to find the PDF first. What will the PDF be? The question is, Let us again draw. Whenever two variables are given, we can draw the values they can take at least. Random variable x and random variable y. Tell me what is the equation given to me? X plus y less than equal to 1, x greater than 0, and y greater than 0. So what are the regions? And I would love to see the distribution of this, the distribution function of this distribution, the CDF, I mean.
So it will be basically the straight line y equal to minus x plus 1 and the lower side of that straight line.
There's only one, right? So x plus y equal to 1 is this line, right? X plus y equal to 1. Yes or no? Correct?
Yes.
And anything? So all this area is valid? Yes or no?
Hmm.
Is this area valid? Is this area valid? Is this area valid? Is there any density you will get there?
No.
It is told uniform in between this region. Right? So it is between greater than x, greater than 0, and less than this line. As Partho told me, it is going to be below the line and above in the first quadrant, right? Good. Now my first, so what would the CDF be? Now you see they cannot be independent. Why they cannot be independent? Can anyone tell me? Like the intuition at least, because you are for independence.
Because y is dependent on x by that equation. X is
very good.
dependent
so
on y.
So y is dependent on x by this equation itself. So they are not independent. This is the answer. Good, very good. So now tell me, what would the CDF or the PDF be? It is easy. We just have to calculate the area since it's uniform, and so this is constant in this area, right? Let us define this area as a in A.
Yes.
So the integral of fx y xy in this area A dx dy is gonna be equal to 1. Yes or no?
Yep. Yes.
But I know this area already. What is this integral? It is equivalent to the c into dx dy in this area is equivalent to the area of the triangle or not?
Acha, you are assuming uniform.
It is told uniform mass is present in the triangle.
Oh, acha, then it will be C. Yes.
So this is the area of this triangle, right? So what is it? Has anyone any doubt regarding why is this going to be the area? This is going to be half into base into height is equal to half.
Half.
So C is going to be equal to 2. Agreed? Now, so f of x comma y, xy. So let me just note it down in the side. So my first answer is if xy is equal to 2 if x plus y less than equal to 1 and x comma y greater than 0 otherwise. So my CDF is defined. Okay, the PDF is defined. CDF I won't do. There are a lot of cases. It will just waste my time. You just find out all the cases and do the simple calculation like I did in the previous question. So let us do. Next comes the interesting question. What is the marginal? Before that, did you understand what is the joint PDF? This is the joint PDF. Did you understand? How did I get it? If there is, I'll wait for one few seconds and then there is no doubt I'll proceed to what is the marginal. I'll do number 4 first. If there is any doubt. Okay, so this is easy peasy. Good. So now, what would be the distribution of x? How do I find that? Right? Before I go and find this, let me just show you why it is going to be that. Can anyone tell me what would f of x be? If I am given, if given fxy of xy and y, and then I'll be able to derive this. See, I can easily should derive it and intuitively give you the answer, but once you are able to derive it from the 0th rule, it will be easy later on.
So it will be y integrates from minus infinity to infinity.
No, I will not do integration here. I want without integration. I have been given the distribution function. So distribution function I have been given. So I have given x less than equal to x.
Oh,
This is why I'm telling
y less than equal to y.
Yes. So this is equal to fx. This is y already given to me as a function. So I know the function. So what should I put the value of y to get f of x? Very simple. Very good, Chirag. Infinity. Infinity. Why infinity, Chirag? Since you have answered one more step further. So if I put y equal to infinity, why will it just give me the thing that I want? Very good. So y less than equal to infinity is nothing but your entire sample space. Yes or no? This is why I'm telling you, remember the definition. Is it clear? So intersection with the sample space. So so you see now this set becomes if probability of x less than equal to x intersection with the sample space. So if sample space is the universal set, with if you take intersection with that, you are left with the set itself. Right? Did you get or not? Did you get your f of x, capital F of x?
Yes. Yes.
Very good. So now you tell me from this definition, how do I do it in terms of CDF? It is equivalent to integrating minus infinity to infinity, as Partho was telling me, f of x, y, dy, right? Integrating the y variable out. This is called marginalization. Okay. And therefore, this is called a marginal. The noun and the verb. Right?
Acha,
Okay.
Minagda, over here, that small f of xx. So if would have been capital F of xx, then apart from the minus infinity to infinity y, I would have a 0 to x, right? An integral.
No, but you mean this capital F of x?
Yes. To find out
But that I
this,
already showed now. You're given the joint distribution. Just put y equal to infinity. It is done. So f of x comma x, if you're given the joint distribution, just put infinity in y. You're done, right? We showed just now the proof. And that's equivalent to integrating from minus infinity to infinity on the density. Yes or no? We have seen that.
yes, but you also need to integrate 0 to x.
To get from f of x to f of x, capital F of
Yes.
x. Then it becomes
Yes.
then you can do all the normal mathematics. We'll see just now. From here to here, you just
That's why.
integrate from 0 to a or minus infinity to x. Right? Then you can do all the normal mathematics. Let's do it. So you tell me, since what is f of x here? So what will I integrate it over? To dy. Right? From where to where will I integrate? Now there's the question. It is not independent with the limits of y.
0 to 1 minus x.
Let us see why. So people who didn't understand, follow me carefully. Why is between 0 to 1 minus x. So say you are given a value of x. This is given to you. Given. So it is given to you. So what are the values of y? What are the values y can take? Someone else? What are the values y can take?
1 minus x.
Only 1 minus x or 0 to 1? It can take anything in between in this. So anything in between these two, right? Utrij?
Yes, yes.
So 0 to 1 minus x. So now you understand where when dependence come into picture, you have to see how the variables are related to one another. You can think of this as obesity and height, something like that. Obesity and weight. Both cannot increase and similarly so on. So 2 into 1 minus x is your marginal. Good. Nice. So now, we have found the marginal. Yeah.
Tata, here we are means excluding that infinity part because we know that beyond that it is 0. That is
Correct. Yes. Just as we do it in normal uniform distribution, right? It is 0 everywhere. The density is 0, right?
why. Oh, yes, yes.
Correct. Very good. Now tell me. Now my question 3 was, now comes the interesting part. How does the variables, how does x comma y interact? And big question mark. How does x comma y interact? So if I'm given y, can you tell me something about x? That's the idea. So that is, I'm given y. Can you tell me something about x? This is also known as the conditional distribution. Okay, let us define the conditional distribution first. So give me the idea, what would be the conditional distribution of f of xy? It's always easy to define in terms of distribution than densities.
So it's gonna be P of x
Probability
such
of
that y
x less than x, given that
x
y
less
is
than
less than x.
such that yes.
Very good. Everyone clear? So this is the definition. Now, once I have this definition, I can do all mathematics. But in books for UG people, it will be just defined as the formula. So try to define everything in terms of events. It will become as clear as water. So what is this by Bayes rule?
Ota intersection ota by P of y less than y.
Now see, what is this equivalent to? F of xy, x comma y. Yes or no?
By marginal CDF of y.
Good. So now you see everything is falling into place. It's any probability things you could write, you can write in terms of distributions as well, right? Bayes rule also holds for distributions. Yes or no? Bayes rule holds for distributions also. Clear? Any questions? I think it's my tablet is not updating. Okay, so I guess there is no question. So now tell me what would be the distribution of this, the densities in terms of densities? It would just be the ratio of these densities as well. If it may be a bit counterintuitive, you have to take derivatives, dx dy. First, you have to take a derivative with respect to x, then with respect to y. And then you will be able to see what is the density, right? Let us do it. If you have any So what would be the, what would f of x y x given y be? What would f of x given y be?
That integration of x and no. Uh, differentiation is
I want it in terms of this. So double differentiation of this joint, right? So both random variables are given to me. I'll take a double differentiation. So what will happen to the numerator? So if I differentiate with respect to x, which one will only change? First, let me differentiate with respect to x.
the numerator will be differentiated upon the denominator
Good.
will come out.
So 1 by f of y will remain ddy, and you will partialize. So one of the variables will be gone. So your f of x comma y. So where is it? So how do I write this? So into ddx of this, right? Just the numerator will be differentiated. Now what will I do? Now what rule will I use?
This will become small fxy.
See, denominator now has y also. So I will have to differentiate using u by v rule, right? So my numerator will become d squared dx dy fx y xy into f of y minus what? ddx fx into f of y by
F
what?
of y whole square.
F of y whole squared. So in that case, you would be able to, so if you go about, so I think there an error. So you will have fx y xy into f of y minus f of y into, so this derivative. So essentially you're not getting this using the double derivative definition. So we'll have to, so this is why
I
probably
guess
will
it will
not get.
be marginal
Yeah.
of PDF of x.
So not marginal, because it's a derivative, right? You have to define these derivatives. Minus infinity to x, minus infinity to y, dx dy. Then you will get it. And then you take the derivative. So a little bit of calculation and you will see. So you'll have to define this and see. So that's why it's also very intuitive. But what will you get is f of x, the joint distribution by the distribution of x, or here in this case y. Okay, so you'll have to take the differentiation and then check, as in this case. But generally speaking, since this is the ratio of these two, we can also solve it a much simpler way. What is the simpler way? Instead of taking derivatives, can you tell me?
We'll do base rule.
Base rule and all we can do, but we have already done the base rule over here. So on the right hand side,
do for small
I
f.
can write, yeah, I can write this as an integral of minus infinity to x. So this is much simpler instead of taking the derivative. F of xy dx dy. Okay. Similarly, you can write fy as, what can you write this as?
That minus infinity to y.
Minus infinity to infinity and minus infinity to y, as you told me, of fx y, right? Right. So here minus infinity to your x will be removed automatically. So you'll be left with minus infinity to y. Is this okay? I guess this is okay. Right?
Yes.
There's no doubt. You are saying yes. You are saying yes when I'm writing two integrals into one integral. I'm taking the integral. I'm integrating x out, right?
Yes, so it's gonna be only you dot x comma y.
Yes. So what will your, so what is this gonna be? Essentially, this x comma y, pi f of y, can be thought of as a fraction of minus infinity to whatever minus infinity to x that you have on the numerator will convert to what fraction? Can you see the similarity between these two? These are just integrals. If you take the derivatives, you would get back the similar densities, right? So if you do the derivative, or if you just take the ratio, what is the ratio of the densities? What is the ratio of the density? So do you agree there will be a minus infinity to x somewhere, since x is the variable that is
Yes.
conditioned on, and you will have an interior variable which will be between minus infinity to y fxy xy
If
by
xy or by fyy.
by very good, because the integrals are from the same range, that's why, and the outer integral does not depend, in the inner integral does not depend on x. So you can refer to this as the conditional density, yes or no? So your x given y, x comma y, so this is much simpler. Instead of taking the derivative, it's just going to make the calculations complex. Is it okay? This is why I'm telling you densities are much simpler to work with, because they are probabilities. Distributions are much more simpler because they are probabilities. You can use base rule directly. But in case of densities, they become a bit more complicated, because you can also use probabilities, but you'll have to be a bit careful. Is this okay?
That mathematically, is this means possible? I have not learned this yet, that dividing one integral by other with same limits.
It is not. I'll show you why it is possible in this. It is not possible direct always, not always possible. The reason is, what is x comma y x this mean? I was trying to give you the intuition, but what does this actually mean? It means the probability of x approximately between being equal to x given y approximately being equal to y. Okay. Utrij, it is the actual definition. You're very good, very right. But why will it hold? I'm going to show you just now. Very good that you
Yes.
pointed out. You're paying attention. So, but do you agree that I cannot? I gave this intuition in the first class that we cannot define distribution probability for one point, but we can define them for a range, right?
A range of
One point
points.
is correct. So I can define it between x and x plus delta. Yes or no?
हाँ थोड़े epsilon हाँ.
Yes.
So now you are getting me, Otrij, why I wrote that integral like that. The reason is this. Always ask questions. This is very important. Very good. So x has to be between x and x plus epsilon or x plus delta, and y between y and y plus delta, right? Agreed? This I can write using Bayes rule.
Yes.
Now you tell me what will be the numerator. What will it be? Bolre. Double integral x থেকে x plus delta y to y plus delta, right?
Yes. fxy dy dx.
এবার বল. What will that be if delta limit delta tends to in 0? Good, that you're interested in maths. I'm very happy. So yes or no? Agreed?
Yes. Yes.
So if delta tends to 0, I can take limit on both numerator and denominator separately. Yes or no? That I can do.
Yes.
That is always defined. Limit of a by b is equal to limit of a by limit of b, right?
Yes.
So the numerator কি হবে বল?
Oh, then fx x comma y
Very good.
into
fxy into delta square. Yes or no?
yes. Yes.
Trapezoidal rule তো.
হ্যাঁ, trapezoidal rule.
হুম.
And denominator হয়ে যাবে f of y.
fyy
delta.
into delta. Yes.
Correct. So delta cancels out. So see, am I getting the same form? This is what I had told you in the first class. The probability of x approximately equal to x given y approximately equal to y. So this is your density, right? Density times delta was your probability of approximation. So this was your density. Okay. We could have done this
Yes.
directly.
Yes. Honestly.
Very good. So we could have done this directly, but I just wanted to show you the other ways as well. Anyways, then you tell me what is going to be the distribution of the number 3, f of x given y, x comma y. What is this going to be? So recall, f of xy was equal to 2 in this range, and your f of y is, so f of x comma y by f of y. What is this going to be? Numerator is 2 in area, 0 otherwise. Denominator কি হবে? We have already found this.
2 1 minus y.
Good. I have found for x, so by symmetry, it will be 2 into 1 minus x. This is equal to 1 by
minus
1
y.
minus. Y. Correct. Because the variable is y. There we had defined for x, right? Okay. Thank you.
Yes.
Now tell me, what is this distribution? What is x given y? You should be able to tell me. I have taught you this one. Anyone? How is x given y distributed as?
Uniform.
Uniform 0, 1 minus y. Yes or no? So the intuition is first you sample from x, or in this case I we are sampling from y. And then if you have sampled from y, I will give you a homework. Okay, do the same sampling. Sample this in Python and print a scatter plot. You will not do it independently. Okay, you know how to print a scatter plot. You will be getting plots like this. Good. You understood the homework, right? Sample according to this distribution. You have done it many times now. Try doing it for this as well. So first you will sample for x. In this case, sample from y. How will you sample from y? Y will be uniform 0, 1, right? This is what conditional distributions mean. So one depends on the other. X depends on y. So first I have to, step 1 has to be this. And then step 2. Okay? Understood? So after I have got y, I can just put the value of y here and sample from uniform 0 to 1 minus y. Agreed or not?
Yes.
Others? Is it not okay? Once I know y, I will be sampling uniformly between 0 to 1 minus y. Yes or no? For x. Okay, this is simple.
Yes.
Good. Now I am told to find expected value. What would be the expected value? Again, by definition, we can use the definition directly. Let us do it at the end, otherwise I'm taking up space for other questions. Expected value of y given x. Or have I written x given y? What will this be? Again, by definition, by Lotus, what will you get? X into?
It will be x, yes.
Is this okay? Uttrij okay? Chirag okay? Brahmudit okay? This is again Lotus. Okay. So what is, we have already found this, right? So let us find the expected value now. So what is the f of x given y, x to y? What is this value? We have found to be 1 by 1 minus x. Yes or no? Again, I have written 1 by 1 minus y, right? Y is given to you. That's what we found. Yes, 1 by 1 minus y. Now tell me, what would be the expected value? X given y. What are the possible values of x? Tell. What values? How is x given y distributed as? We did just now. Uniform?
0 to 1 minus 1.
0 to 1 minus 1.
Very good. Check the distribution. Check its
1 minus
range.
y হবে না?
1 minus y হবে না।
আরে ঠিক আছে ঠিক আছে, ওই বারবার প্রিন্টিং মিস্টেক হচ্ছে। But understand the idea. তাহলে next what will happen? X square by 2 or 1 minus y square. Understood?
Yes.
No doubt. So what did we see? We see that expected value of x given y is a random variable of y or function of the random variable of y. Always remember this. When you will like study more, you will see it's a y measurable random variable. I have defined what is measurable random variable last time, but it is not required now. So remember in this case, y is given to you. So y, x given y is a random variable. It's not a number. Okay. Because y can change. I can change y, and depending on that, expected value of x will change. Yes or no? For example, if I draw this, you see the intuition, I can give you this as the x or the y in this case. And this will give me expected value of this as the expected value of x given y, right? It will depend on y. Yes or no?
Yes.
Okay. I hope there is no doubt. So we have found expected value also. We have done lotus. We have done conditional distributions. The last part of it is trying to do covariance. Hence, and we have been also told to find f of x. That is very simple. But yeah, let us do that simply. What is expected value of x? How can I do?
কি কোনটা বললে?
So say you have expected value of x given y, right? Given to you. This we have
Yes.
found 1 minus y by 2. Right? Covariance and correlation you will find. I'll give you
Yes.
what is the idea. I have already given you correlation. Covariance you will also find. Correlation, I'll show one proof. That will be enough. I'll want you as a homework. I don't want you to waste time doing calculations. So this is a random variable. Agreed? Right? Capital Y, if you are confused. Y is a random variable. Okay? Any doubt before I proceed? Now tell me, what can expected value of x be written as? Do you see it can be written as double expectations? This is also called iterated expectation. You have to show me why. Can anyone show me why is it the case?
আচ্ছা একবার ইন্টিগ্রালটা দেখাতে পারবে?
Which integral?
The e of x such that y এর ইন্টিগ্রাল স্ট্রাকচারটা একটু দেখাতে পারবে?
This
যেটা
one.
হ্যাঁ 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 হ্যাঁ।
This is x given y. This is simply lotus. It is a distribution over the conditional distribution. Right? This same conditional distribution you have to use. Okay? Conditional density, whatever. And then whose expected value are you told to find? Expected value of x.
x. ও আচ্ছা বলবো এটা যেটা
one?
আজ করলে মানে মানে
Yeah, sure.
যেটা
Go
যেটা
ahead.
iterative.
Speak in. Yeah. Go ahead.
So basically we are getting the expected value of x with respect to some y. So this
Correct.
respected
a-
averaged over all the y's.
That is the intuition. Very good. Very correct. Very good. Absolutely. It is averaged over all the y's. Very good. But how do I show it mathematically? So this is you understood now that this is a random variable, right? That x given y is a random variable. Because it is defined in terms of y.
হ্যাঁ আমি যখন x টাকে লিখছিলাম
So I will write this
মাইনাস
as
ইনফিনিটি থেকে ইনফিনিটি
f of x given y, x comma y, right? Into x.
ইন্টু
dx,
এক্স
right?
dx dy
Minus infinity to infinity.
দুখানাই মাইনাস ইনফিনিটি থেকে ইনফিনিটি।
Correct. And this will be the outer integral is defined over which random variable?
Outer defined over y.
Very good. Because we have already shown it's a random variable of y. Good. So it is f of y, y dy. So now this integral, this is over y, this is over x. The initial internal integral does not depend on y. I can take this integral, this value inside. It's a constant for with respect to the first integral. F of x given y, xy. So this is nothing but the joint right? Yes or no? Agreed? Swap the integrals since PDF is defined.
মাল্টিপ্লাই করে
Overall.
দিলে হ্যাঁ
Yes, I multiplied and used base rule as I showed just now.
yes
Base rule, and then x can come outside, f of x comma y dx dy dy, right? I just swapped the integral. I have not done anything else. So this, what will happen? Marginalize over y. So y will be removed. Correct? Yes or no?
yes
So I'll be left with x f of x dx, which is expected value of x. Correct? Clear? Okay. If it is not clear, I'll wait for 1 second. Good. So now how will I find the expected value of x here? Tell me. Yes or no?
কোনটা বললে
Is it clear that we can take iterated expectation as you told me, average over all the values of
yes
y
yes
to get the value of
Yes.
expected value of x? Okay, someone else tell me how will I solve this? So this is the expected value of the distribution y, 1 minus y. So this I already know. I have calculated from this 1 minus y by 2. This is half minus expected value of y. Now what is the expected value of y? How do I calculate? Here it's essentially boiling down to the same thing. You have to
হ্যাঁ তো
calculate the expected value of x and
হ্যাঁ
y.
ওটা
Anyways,
ইন্টিগ্রাল অফ y ইনটু fy
go ahead. Expected value of y, how do I calculate? It
that
is
integral of
integral of,
y into fy
yes, from 0 to 1. What is fy? We have already found out the marginal. Anyone else?
0 to 1
What are the
fy
values of y? Yes, what
0
are-
to দাঁড়াও,
What values y can take?
0 to 1 yes okay
So what is f of y? We found the marginal was 2 times 1 minus y, right? As far as I recall. Yes, it was 2 into 1 minus y. Yes or no? If you have noted
Yes.
it down, yeah. So then, what is expected value of y? This is equal to integral from 0 to 1 y 1 minus y dy. What is this value? Half minus 1 by
half
3,
minus 1 by 3
which is equal to 1 by 6 or 1 by 3, right? So your
yes
expected value of x is equal to, we have already found the question. I wanted to show you the iterated expectation, but we have already found expected value of x will also be equal to 2 into 1 minus 1 by 3, which is equal to 1 by 3. Can anyone tell me who has seen this thing before in physics? What is this thing actually? I have given you the thing last day in class.
কোনটা বলছো
So the expected value of x comma y, you should have seen this. It turned out to be 1 by 3 comma 1 by 3. You have seen this in physics, I'm saying before, and I had given that intuition in terms of moments last day. Yeah,
center of
go
mass
ahead. Yeah, the center of mass. The center of mass. So if you were intelligent enough, you should have been able to tell me it was like I was not intelligent enough when I solved this question, so I had to do it entirely. But if I had seen that it is the same question as finding the center of mass, I should have been able to do it immediately as 1 by 3 comma 1 by 3. It's the center of mass. It's a uniform thing. Okay. So what is covariance? We have defined before. You will try and do it. I can also do it, but anyways, let's do the covariance. The correlations you can do as homework. Correlation, I'll just tell you the formula and the thing property of it, and then you can do it as homework. Okay.
Dada, one thing to ask means
Go ahead.
while yes, here while we were doing x given y, then we were considering y was constant, a random variable that was constant for that. But
yes, let me complete. So for a particular value of y, if you fix y to be small y, then it is constant. But y can be a variable itself, right? Y can change itself. So then it becomes a random variable over y. So this is a parameter which you can change. Yes or no? Over all the values y can take. Is it clear, Ashmi?
Okay. Yes.
I guess you understood, right? So it is exactly like a distribution of say g of y, isn't it? It is exactly right writing a distribution of y. Like I'm getting the, are you getting the feeling? Is it exactly writing? Isn't it exactly writing the distribution of y?
Yes. In for x.
Correct. And it is going to be a, the intuition is, since you're taking the expectation over x, x will no longer be remaining, but your x is dependent some way on y, therefore it will become a random variable on y or a function of y. So some z function of y. Good. So covariance, do anyone recall number 5? What was the formula? How was it defined? We had defined it. How x and y
E of
vary with,
xy minus E of x, E of y.
we had defined how the two vary across their mean jointly, right? We had defined this in the first or the second class. For a single variable, we saw how it varies across the mean. For two variables, how they jointly vary across the mean. That's the idea. So this is expected value of xy, as Partho is telling me. If x and y are equal, it boils down to the variance. Recall. Go back and see if you have not recalling. Good. So what is expected value of x comma y? Xy, not x comma y. Xy, now you will tell me how do I solve it. Can you tell me? Now is you have to use which distribution? This I already know. 1 by 9 or 1 by 3 into 1 by 3.
বলবো
Yes.
মৈনাকদা?
Yeah, go ahead.
Expected of x into expected of y such that x.
You can write that expected value of x into y such that, no, you don't need to do that. You can do that, but can we write it directly in terms of the write directly? Now you don't tell me, someone else please try. If you want to try, of course, I'll wait for a minute and then we'll go ahead. So this is remember, this is your, so what is the expected value of xy be? Lotus, what will Lotus tell me? Yes or no? I will have to take the expected value over the joint. Again, Lotus. 2D Lotus. Okay. Any issues?
No.
Okay, then you tell me what would be the ranges of the integral. What is f of xy? That value we have already seen. What is the density value? It is uniform. So it is
2.
2. So 2 I'll take outside. Xy dx dy. Now tell me what would be the ranges of the value. So do you know how to do double integrals? How to set up ranges for a double integral? I will teach you. Let me teach you here itself. So in people who are in first year may not have seen how to set up integrals as double integrals. So if you have to set up an integral over this area, there is something called as a file rule or column rule. So these are called volume rules. So for a particular x, you have to see for one particular x, what are the values of y it can take? What are the values it can take? For one x, y can be between 0 and 1 by x, 1 minus x. Yes or no?
Yes.
I know x, so y can be in between 0 and 1 minus x. Are you following? So now you tell me what would be the limit of x? From where to where x will vary. So let me write x outside. So whichever is the whichever variable you are taking as the independent variable, keep it to the end. Like I have kept here. So what are the values of y can take? Well, x can take between
X
0
can
and
go
1.
from 0 to 1, yes.
Very good. So this is how you set up the integral. You can go from here to here. But depending on the value of x, where can y go?
This is the 0 to 1 minus x we found.
Very good. This is how you do a filing rule, column rule, cuboidal rule in multivariate calculus. If I get time, I'll try and show you some more methods how to calculate areas and volumes using multivariate calculus and write multiple integrals. Anyways, but I think I have been able to convey the equation. You should. So in 1D variables, you take x and swipe it over x plus delta. But here what you will do, you will take from x plus delta and then take all the values between 0 to the limit of y. And then take a small cube. And that would be your dx dy area. Right? That's what you're getting. This is the area, right? Partial area. I hope that is clear.
Just one thing for curiosity. Suppose fxy is in terms of xy, a function is given. Now, when we are integrating for the dy part, so we have to keep x constant and do that.
Exactly. That's what I'm doing, right? So not curious. It's very good. You keep x constant and then see all the values of y. And then you can go from y to y plus delta. So you get a cuboid, isn't it? So dx, dy, you will get a cuboid, isn't it?
Yes,
like
understood.
a square, and you will get a z value, and then you will be able to integrate that double integral. Double integrals are volumes, single integrals are areas. Simply. Good. So tell me what would this be? So first integral is on the value of y. So be a bit careful with the limits. Here, so x would be a constant, right? I'll take x out. 0 and y, x, 0 to 1 minus x, y, dy, dx. Okay? When if you're confused, write it this way. Then all confusion will flee. Then you will get 1 minus x square by 2. So x 2 and 2 cancels. 0 to 1 dx. Okay? This is what you will get. Any doubts? This is essentially integral of x plus x cube minus 2x square dx. Doing this calculation may be seeming to be very cumbersome, but this is what will set your neurons together. You will be able to understand how to do things. Otherwise, you can never understand. So half minus 1 by 4 plus 2 by 3. What am I writing? Plus 1 by 4 minus 2 by 3. Yes or no?
Yes.
So what is the LCM? 12. 8, 16, 24. 12 is there, no? 12. Okay.
12.
I think, is this calculation all right? Let's check once. Y square by 2 minus 2x, x cubed by 4, cubed by 3. Let me just check. So it will be 4, 6 minus 3. 6 minus 3 minus 8. Again, I have made some error. It cannot be positive. How do I know it cannot be positive? Can anyone tell me how am I telling you it cannot be positive? X into 1 minus 2x plus x square, x minus 2x square plus x cube. Where am I making the error? Half help me out. Where am I making the error? So 6, 3, 6, 4. Have I written the integral correctly? I think I have. Oh, it's okay. I think it's okay. So 1 by 12. It is okay. I was confused because this is what? This is the expected value of xy, right? This is what happens when you are becoming old. Expected value of xy is 1 by 12. What is the expected value? What is the covariance? Someone?
So
1 by
12 minus 1 by 9.
Good. So this is 36. This is what I was thinking. How can it be positive? 3 minus 4. So you get 1 by 36. So why I was sure that I will get negative? Can anyone tell me?
Oh, because the means you were sure that you were because as x goes up, y goes down.
Very good.
That's why.
That's the idea. So as x goes up, x is going up, y has lesser space to go up. X going up would imply y going down. I would tell you to find the correlation between x, y. I'll tell you what it is and prove that it is equal to minus half. It has a strong correlation, negative correlation. I'll show you what is the correlation and I'll show you an important property of correlation, but I'll not solve it for this. But I have done it already. Or for this, you just need to find out so correlation is defined as, this covariance, again, what is the issue with covariance? It has a unit property, right? It has a unit. Yes or no? If it is centimeter, you will have centimeter square. But your internally x and y can have different variances, right? To bring it into the same footing, we divide by the standard deviation of x and y, and we define this as the correlation or the Pearson's correlation. Okay. So this is the definition of the Pearson's correlation. You divide by the standard deviation of x and y. Now show that Pearson's correlation is always between -1 and 1. Can anyone tell me how to go about this question? So Pearson's correlation is expected value of x minus the mean, y minus mean, by square root of expected value of. If you are not following here, tell me. Are you following? Is this okay? Any question? So I have the covariance and just these two numbers. If they have say x has very high variance, so automatically covariance of x comma y will become high. So I am trying to scale, normalize the covariance of x comma y based on the individual marginal variances of x and y. Is the intuition clear? And then I'll come to the math. Okay, this is just normalization.
Acha, so means it is a product of the stuff of x and y.
So
So
rho
I'm
becomes
just
unitless. Ball. Help.
So it is the product of the deviation of x and y. So in order to prevent it, order to make it lie between -1 to 1, you
Not only -1 to
normalize
1.
it.
You cannot ideally tell me the value of. So see this, x minus expected value of x. If this is only very, very large, or anyways your x minus x cap will become anyways very large when you multiply with y minus y cap, right?
Oh yes, yes.
So, but you will not be able to put it into the same footing. So you will not be able to see the interaction between x and y. You will see the effect of one variable only. That you want to stop doing. So covariances are not reported in any scientific studies, only correlations are reported, which is unitless. You don't want centimeter square to be a limit between height and weight, or centimeter kg to be a unit between height and weight, right? How is height and weight related? You don't want their unit to be centimeter kg. You want them to be unitless across all terms. Anyways, so let us take this as, let us think that x cap is 0 and y cap is 0. For without loss in generality. Why is it without loss in generality? Can anyone tell me? Without loss in generality. Say if your y cap was not equal to 0, how can I make x cap equal to 0? What is x hat? X hat is the expected value of x, yes or no? Okay, coming back. I'm coming back to the same equation. If x, this equation, say your means were not equal to 0, right? So your means were not equal to 0. How can I, without loss in generality, say कि x minus x cap can be replaced by just x, and I can just replace x cap with 0. Correct? I can just define an x tilde defined as x minus expected value of x. Yes or no? And a y tilde as y minus expected value of y. Now is the expected value of x tilde equal to 0? Expected value of y tilde equal to 0? Am I audible?
Yes.
No.
Yeah.
Expected value of x tilde is 0, expected value of y tilde is 0, that is clear. But but that without loss of generality thing is not clear. I mean, what are we trying to say?
Yes. So the idea is, so instead of using this, I can just replace this as a different variable. That's what I am meaning. Right? I'm defining x as x minus x cap. So if you have a random variable, right? Any random variable, you can make it a mean centered random variable by just subtracting the mean always, right? And then you will, then the entire thing should hold. It should not depend on an offset, right? It should not depend on the mean of the distribution.
Acha.
It is. Go ahead.
Moinakta, this reminds me of something we did the earlier day. In order to transform any random variable x into a normal 0-1 distribution, we did x minus mu by sigma.
That is exactly. But here you don't. That is exactly right. But here you don't even need an analogy. It is true for any random variable. If you have any random variable, I can write that random variable as 0 centered by just subtracting the mean from all the data points. Yes or no, Brahmajit? Brahmajit?
Yes, sir.
And then I can do the same calculations again and again. There's not going to be any issue, because there's a 1-to-1 mapping between the 0 centered random variable and that variable.
So expected value of x minus x bar can be replaced by expected value of x tilde.
Yes, expected value of x tilde. Very good. Or you can just think of taking variables v and w. That's it. There's nothing else. Okay, so now I have to show that this is less than equal to, greater than equal to -1 and less than equal to -1. So your covariance and variances don't depend on the unit. We have already shown does not depend on constants. That's why it's not depending on that constant. It is, you can just remove. It's linear in that constant ranges. So it does not depend on constant. So how can I show this? Any idea? This is a property, very important property. Okay, let us start. It is not trivial. So what is x minus y whole square? X square plus y square.
One thing. Yes,
Go ahead.
in the numerator, that is e of expectation of x into y. It should be.
ভুল হয়েছে ভুল হয়েছে ভুল হয়েছে সব ভুল এক্সাইটমেন্টে ভুল হ্যাঁ নাও টেল
তাই বলছি তুমি এখন ইন্ডিপেন্ডেন্ট বানিয়ে দিলে তো তাই
yeah forgive me all these things happen because I was thinking 5 steps ahead so I didn't see what I was writing sorry no it's not independent at all sorry for the confusion thank you Otrich so do you see so this is true for anything yes or no this is just your x plus y whole square so I can write 2xy less than equal to is it less than equal to I drop this is always greater than 0 so if I drop this my right hand side will become what would the inequality be 2xy what would the inequality be this is greater than 0 if I drop this term
less than equal to
less than equal to because this right hand side is equal to total of this term but I'm only writing a part of this and there is a positive value very good now I will take expectation on both sides okay so I'll get expected value of xy less than equal to expected value of x whole square plus expected value of y square
টুটা কোথায় গেল ও আচ্ছা হাফ
yeah so now tell me how do I convert this to this form again I can do another trick I'm only playing tricks now I'll write x as or say v as so I'll write x as v as expected value of v square can I write and y as w by expected value of w square is it okay if I can I define I'm just defining x and y to be in terms of two new random variables the denominator is a constant in both cases yes or no
yes
so now what is the left hand side going to become expected value of vw by expected value of
vw করে ওই কনস্ট্যান্টটা বেরিয়ে
yeah v square and the right hand side what will it be expected value of v squared by constant as you are telling me will go out plus expected value of w square by expected value of w square so you see you can do the same thing with the offset also it's just to make the calculation easier that I kept the offset is it matching now so you have vw less than equal to expected value of v square expected value of w square this is also known as the Cauchy-Schwarz inequality understood any doubt so now how will I prove correlation is using this definition how will I prove correlation is between 0 and 1
হ্যাঁ ওই যে মানে RHS টাকে এইদিকে আনবো I'll divide it
no but it is I have to take square root right
I have to do square root yes
is it just a moment sorry this has to be the square root of this isn't it on the right hand side I'm taking a square right just to be clear okay This is the Cauchy-Schwarz inequality. So in this case, the right hand side can be, so if you divide this, what will you get? Expected value of VW by V squared into expected value of W squared will be less than equal to 1. Ideally, this should be mod of V and mod of W, because W, the product, we do not want to change the signs, right? We do not want to change the signs. So if you have mod on both sides, if you remove the mod, you will get -1 to 1. Is it okay? So the correlation always ranges between -1 and 1. Yes or no? Do you understand? So please find the correlation for this random variable, this joint distribution. It will be clear. Okay. Any questions? Any confusions? Ask and it may be cleared. You understood now why I took a mod. Otherwise, VW can become positive and negative, and inequality will flip. You have to take all the cases. If you haven't understood and you think that it's just thinking thing, go back and think. It's just flipping the inequalities. Without flipping the inequality, what you can do. Anyways, so let's see a simple question. Let us do this number 3 question first. So you have xi distributed as Poisson distribution and n distributed as geometric p. What is the expected value of z is what you are told to find. We have already shown this iterated expectation. Now you tell me, how will I use this? So it's known that I equal to 1 to n is z, but n is given by geometric p. If n is given by geometric p, for example, every time I fail, I'm going to add a Poisson random variable. See, I put a coin toss. If it is tails, then I will have a number of nodes circulating packets. And every time, so the number of packets circulated at the end would be the sum of number of times I failed and each time how many number of packets were circulated, right? Any questions? So is the question clear? Is it okay?
বুঝতে পেরেছি.
So this n is a stochastic thing. It's not known to me. So if it is not known to me, what will I do? I'm gone. I cannot do any expectation, any linearity I cannot use. Yeah.
Moinakda means one part is very unclear to me. I can't understand that. That is that what is the difference between random and stochastic?
Random and stochastic is the same thing.
Oh. Acha.
Yes, they're different names. The same. Ma and mom. Good. So what will this be? Any idea? What will expected value of z be? How do I go about solving this?
Can I break it up into the sum like I did, like the indicator variable?
You cannot, because n is not known. How will you know n?
না মানে expectation তো linearity ওপর break করা যায়।
But
তো
this
মানে
n is stochastic. This n is not known. N is distributed according to geometric p. You can do linearity, but what will you do with n? Isn't it?
Dada means we can first start with a fixed n and then
Very
vary.
good. Very good. So as this is what exactly. So I will take our iterated expectation, right? Z given n equal to n. Agreed?
yes.
So I will be able to As soon as I do a iterated expectation, my problem becomes 1 second solved. Done. Given n equal to n, your z is distributed as I equal to 1 to n, I equal to small 1 to n xi, where xi is Poisson mu I mu iids. Now I can easily take the expectation. Very good, Otrij. So I'll get n into expected value of xi. What is the expected value of a Poisson? Mu, right?
It's mu itself, yes.
Correct. I don't think there is any doubt. I have used linearity and symmetric here. Good. So now you tell me what would be the expected value of. So now you see n. Now once you have replaced, you have got it terms of n, you have to write it in terms of a random variable. So Trij, what will I write? I will just remove the parameterization n and write capital N mu. Okay. Now it is a random variable as I was teaching you. Z given n is a random variable of n, right? See the beauty. And now expected value of z would be nothing but the expectation of n mu. What is the expected value of n? N is a geometric p, is 1 by p.
1 by p.
So it's mu by p. Right? No doubts?
আচ্ছা মানে এভাবে মানে যদি if I had a say a double sum, okay, means I runs
Double
from
sums
some.
we will do. Double sums we will do. Don't jump the gun. We'll do. Next day, I think today we'll not get time, but next day we'll do. I'll stop with the law of large numbers today, and then we can do chi-squares and so on next day. Since we have done the more difficult question, please solve these 2 questions at home, 1 and 2. 2 is a very simple version. As I am seeing you're becoming very confident with conditional expectation. Find the conditional expectation for these 2. It is a discrete case. Make a table and find it. It's very simple. 1 and 2, please upload. You have now 5 days. Please upload all the homeworks. So this is a x and y is given. So I'm just making the table for you. So x takes values 1 and 2, and y takes values -1 and 1. So it's everything, all probabilities are given. 1 comma -1 is 1 by 5. 1 comma 1 is 1 by 3. 2 comma -1 is 1 by 5. And 2 comma 1 is 4 by 15. Okay. Please try and solve the expected value of x given y equal to 1. That is y is given to be 1 and y is given to be x is given to be 2. In these 2 cases, what would be the expected value? Please find it and upload it. Very simple question. Good. Now let's see. Now we have stopped learning about basic things. We know now all majority of common distributions. We know conditional expectation. We know conditional distributions. We know joint distributions. Everything is known to us. Now let us use it for one particular case, which is also known as weak law of large numbers, which will be using throughout our machine learning course. So the idea is, say if you have n random variables, 3 ... xn, they are IID, okay, independent and identically distributed, and you define a sample mean. What is sample mean? Can anyone tell me? Say I define sample mean. This is also a random variable. Remember that, right? Sample mean as, so let me define sample mean as 1 by n summation of I equal to 1 to n xi. So n is known to me. X1, expected value of x1 is given to be mu, and variance of x1 is given to be sigma squared. Now I'm asking you, what is expected value of mu n. So this will be using statistical tests as well. So please pay attention. Go ahead. Ask.
We'll use linearity,
Good.
break it up
So
over each of
I
the
will
exercise,
get expected value of
and then
x1
n mu.
n mu. So this is nothing but mu. Do you agree? Expected value of the. So see, on expectation, your sample mean. On expectation, your sample mean is same as the actual mean. Now you tell me, I will, before I proceed, where can I use this technique? I will, and I don't know, I want a new person to ask, tell me. Brahmajit, can you tell me, where can I use this technique? Before I show all the mathematical proof, let us give an example or intuition why I need law of large numbers. Can you tell me? Yeah, AM greater than or equal to GM. Good, Chirag.
I don't have an example yet.
Anyone else? Can you give me an example? So think of coin tosses, na? In reality, what is not known to you? In reality, mu is not known to me. Sigma squared is not known. None of these are known to me. So if I am told if I'm telling you what is the probability of a head of a coin, how will you tell me what is the probability of a head of a coin? What experiment will you do to say a coin is biased or unbiased?
We'll do the experiment and see. Yes, a number
How many
of
times? How many times? Good. How many times will you do? That's what the law of large number.
That is
Yes.
told as the more number of times we do, the better prediction we do.
Yes, good. That's the intuition. More number of times you do, the better intuition, better approximation I should get of mu. So I only know the values of this random variable. Sometimes it can be 1, sometimes it can be 0, and so on. Say 1000, 1 lakh, 10 to the power 5 times. Ideally, I should be able to do infinite number of times to calculate it. So in real life, in reality, X size distribution is not known. But mean is even not known. Mean is not known. We need to redo the experiment to conclude. So let's quickly do the rest of it. Good. So intuition is clear, then the rest of this thing is very simple. So tell me, what is the variance of mu n? Since mu n is a random variable, variance of mu n is 1 by n variance
Expectation of mu n square. Variance of 1 by n of all the exercises. 1 by n tab 1 by n squared, I guess.
Good. 1 by n squared into
1 by n square into
variance of
variance of summation of all the exercises. কারণ independent covariance টা তো
very good.
0 হয়ে
Variance
যাবে।
covariance is a 0. Very good. You remember. So I can take variance also outside n, variance of x1 by n square. So standard deviation of mu n is nothing but, yes or no? Forgive me if I'm.
Yes.
Good. So now my question is, I have to show that the mean will converge. How can I show that mean will converge? We'll show that and we'll stop for today. For that we'll need, so what is the idea? So you see, as n tends to infinity. Go ahead.
I can't understand a very basic thing over here, which is that when you are defining the sample mean, so over here the sample is basically I'll take one value out of each of the exercise and then I'll create a sample.
Yes, you will do an experiment and you will do a sampling. That's why I told you to do sampling, not so many times. Like sampling from a Bernoulli piece, just doing a toss with a bias point of P.
Acha. Okay.
Correct. Good. So the idea, what will I do now? The variance of mu n. I have to show as n tends to infinity. Do you see variance goes to 0? Yes or no? So ideally, I'm getting some constant, but I have to prove that. Again, is it clear? As n tends to infinity, variance goes to 0, right? Limit n tends to infinity, limit n tends to infinity. What is mu n going to? Is it okay? Variance of mu n is sigma squared by n. Limit n tends to infinity, variance. Instead of asking so many times, let me do it. Okay. Next. So, but I have to show that the means converge, right? That I have to show the probability that mu n, the sample mean minus the actual mean, being greater than epsilon, some epsilon is equal to 0 for all epsilon greater than 0. Right? Can I show this? If I can show this, what does this mean? It means probability that the gap between mu n cap and the actual mu n, which is fixed, is less than epsilon, right? It is bounded. Yes or no? And if I can set epsilon to be arbitrarily small, then what will happen by sandwich theorem? Mu n cap will be equal to mu.
Epsilon will become 0.
If I take epsilon tending to 0, mu n, do you agree? Mu n cap will be equal
Mu
to
n will
mu
be
n.
equals to yes.
But for that, I have to show the probability that it is greater than epsilon is equal to 0. Yes or no?
Yes.
That it can. So how can I show that? To do that, I'll show you a simple inequality, which is also known as a Markov inequality. So for that, the assumptions are, so the inequality very useful, just keep an eye out for this, is this. Let us say this is an inequality that a random variable being greater than epsilon is less than equal to expected value of x by epsilon. Where
expected value of f of x টা কি?
I'll tell you. It's where x maps from sample space to real number line. That is mandatory. So it be positive between 0 and infinity, it should map, not minus infinity to infinity. Okay. X must be positive random variable, must not take values in the negative. Okay. Second is f is a r plus to r plus monotonically increasing function, any monotonically increasing function. Okay. Is it okay? Understood what is f, what is x? What are the
Yes.
assumptions? Now, so your f will be something like this. So do you also agree that I can write f of x as f of x into an indicator random variable such that x is less than epsilon plus f of x into an indicator random variable x is greater than epsilon. If you have understood this, it will be done. Why is it you want me? You may ask me. So what am I doing is I'm taking an ask.
ওটা কি এক্সটা যদি মানে ইন্ডিকেটর মানে ওটা যদি লেস দ্যান ইকুয়াল টু এপসিলন হয় তাহলে ওটা জিরো
Yes.
হবে গ্রেটার দ্যান হলে 1 হবে।
ইন্ডিকেটর মানে কি? ইন্ডিকেটর মানে I equal to 1. What is an indicator? I told you na, indicator of an event equal to 1 if
If the event is
omega
a
belongs to A,
yes.
right? So indicator random variable equal to 1 if the event belongs to the important our required set. So our set is, I have defined two sets, 0 to epsilon and epsilon to infinity, right?
Yes.
So if it is 0 to epsilon, I will get this part. If it is in epsilon to infinity, I'll get this part. But it is still f of x, right? I'm just writing it in terms of two terms. Do you agree?
Means
Both
how
of,
can I break it up into two terms?
so say x is less than epsilon. So what will this become? If x is less than epsilon, then indicator of x less than epsilon is equal to 1.
1 আর ওইটা হয়ে যাবে 0.
Yes, only 1 will be there at a particular time.
ও আচ্ছা, হ্যাঁ বুঝতে পেরে গেছি।
So if you have I hope you have understood. So do you also agree that I can write f of x as, again, all these terms are greater than 0, right? So let me write this as less than, let me write this as greater than, just for convenience. I can drop this or not. This is greater than 0, greater than equal to 0. Yes or no? না বুঝতে পারলে বলো, right?
না মানে এই ইনইকুয়ালিটিটা কি করে করলে আরেকবার একটু বলবে?
This one is greater than 0, so I'm just dropping it. Do you agree this is greater than equal to 0?
মানে
F of x
greater
is-
than equals to টা আনার জন্য তো ওই পাশে।
Correct. Yes. I'm
আচ্ছা
just
তো
saying
মানে
it is greater
একটা
than
টার্ম
one
হাটিয়ে
term is
দিচ্ছ।
greater than, yeah, I'm just removing one term.
Similarly আমি inequalityটা I can also write using
Yes,
the
you
x.
can write, but that is not
Yes.
useful in this
হ্যাঁ
case. Why, you will see. This will become a continuous. I hope you're enjoying this now. I'm trying to make you enjoy. So f of x is greater than equal to f of x indicator of x greater than epsilon, right? So now do you also see
yes.
f of x is greater than f of epsilon for all x greater than epsilon? Why?
Because it is a monotonic increasing function.
Monotonic increasing function. So a simple proof. Now I can, so what can I write? I can still continue with the inequality f of epsilon indicator of x greater than epsilon. Yes or no? Right? Because this is, yes or no? And it is always positive. So there is no negative inequality flipping here, right? So I'll get f of x greater than equal to f of epsilon indicator of x greater than epsilon. What will I do now? Fundamental bridge, do you remember? Do you recall the fundamental bridge? Otrij, what will I do on both sides? I'll take expectation. If I take expectation on both sides, what will I get? Fx into, this is a constant, so I can get it down into expected value of indicator of x greater than epsilon. Is this clear? Which step is not clear? I'm waiting for 1 minute. Ask me. Okay, if it is clear, Partho, tell me why did I write this inequality?
Yes, because so you did that f of x is greater than equal to f of x into indicator
The
random
second inequality.
variable.
The first
Huh?
one is clear, I know. Second inequality.
Yes,
No, it's
because since f of x is greater than equal to f of epsilon, since x greater than epsilon, since it
yes.
is a monotonic
Okay.
increasing function, so easily I can write.
So now next I took an expectation on both sides, right? F of epsilon is a constant, I took it to the right side, which are all positive values. So I can inequality won't flip. So what is expected value of an indicator?
Means the event itself, A.
Correct. So what is the event? Probability of x greater
Probability
than
of
equal to
x
epsilon.
greater than epsilon.
Very good. So we have done, this is again the fundamental bridge we proved in the first class. Using the Bernoulli, using n events, sum of events and so on. Any doubt you ask me others. I'm not teaching only one or two people. Right? This is also called the Markov inequality. Now I have to use this inequality to prove that this is equal to 0. Can anyone tell me how to do that? So on the right hand side, I have to bring variance somehow. On the left hand side, I have to bring difference. So I will write, so I will do something called as Chebycheff's inequality. I will prove this. So if I write x as mu n cap minus mu n, right? Or minus mu mod, right? Does it take values and take it between? So is x between the sample space and R plus? This is a
Yes.
constant. This is the mean expected value of mu n. Good. And if I take a function f of x equal to x square for x greater than equal to 0. Again, it is monotonically increasing or not?
Yes.
Now what can I write? I can replace x as mu n cap minus mu greater than epsilon less than equal to expected value of what? Mu n minus mu whole square by what? Epsilon squared? Yes or no?
True.
So what is the numerator? Variance of mu n. Yes or no? This is known as the Chebyshev's inequality. It is true for any random variable though. In general, what will you have? Probability of x minus x cap greater than epsilon is less than equal to variance of x. This is why I was telling in the first class why variance is important. How far can x vary from its mean can be defined by this inequality, right? So now what is the variance of n? Variance of mu n, we define sigma square by n epsilon square, we'll get, right?
Yes.
I put limit n tends to infinity, this goes to 0. Proved. Now, what does this result give me? It gives me the idea that when I have n numbers, n samples of a random variable, then the mean of that random variable is converges to the mean, sample mean converges to actual mean, right? Yes or no? Any doubts? Sample mean converges to the actual mean. Okay, if there is no doubt, Otrich, tell me. So If I am told,
Yes.
if I tell you, I'm telling you to do an experiment, say you have a die roll, you have a roll of a die, or say you have to measure the hemoglobin of women in the world. So if you have to measure the hemoglobin of women in the world, what will you do? You have to tell me the actual distribution of the hemoglobin. What is the actual distribution? What is the actual mean of women? So when women will be born, they will be sampled from that distribution only. What is the mean of that? How will you tell me? What experiment will you do?
So the hemoglobin of each and every means some women will be who will volunteer, their hemoglobin test will be conducted and the value will be taken.
Okay.
And more the
And
moment volunteering, we will find the actual means
more,
towards.
very good. So the idea is, if you have to, very good. So if you have to find the hemoglobin of women in the world, you will be taking a sample of 3,000, 5,000. This is why this is what is done in a survey. It's much more complicated. The vote is coming, election. What will the news channel or any channel do? They will sample from a distribution, sample a few people, ask them ask them some questions. They cannot ask you whom are you going to vote. Say if you're going to be liberal and so on, you may vote for a left party, compared to if you are more conservative, you may vote for a right party. So they will ask questions like that, and they will infer what is your vote, and then they will do it for many people, say 3,000 people, and then they will say with some epsilon accuracy that it is converging to the proportion in which the votes each party will get. I hope that gives you enough indication of how things are done in real life. So in real life, you don't have actual distribution, you just take sample means and sample variances, right? Good. The last thing for today, I've gone over time, but it was to explain different distributions and all. But the last thing for today would be sample. So sample mean we understood. Well, let us do sample variance also. So sample mean you have understood. What is sample mean? So we have defined sample mean converges. So first thing we have understood is sample mean converges to actual mean. Now we'll do sample covariance and we'll stop. Or sample variance. So what will you do in sample variance?
I'll take x is equal to sigma and minus sigma.
Good. So it's so recall your actual expectation was, your actual variance of a random variable is expected value of x minus mu x whole square, right? So your sample mean would be, say, let us define this as s squared sample mean, and let me write SB. Let me write S biased. I'll show why I'm writing S biased later on. What is it? A1 by n, I equal to 1 to n, x minus the sample mean, right? Right? I only know the sample mean.
Yes.
So you have defined it in terms of sample means now. Now why am I calling it biased? Because the expected value, if it is not biased, what will happen? Can anyone tell me? So this is what has happened for an unbiased estimate. The expected value must be equal to the actual variance, right? If it is unbiased, expected value of sample mean equal to actual variance, okay, of the distribution of x1, x2, xn. Okay, I hope that is clear. This is definition of a unbiased estimator by definition. Unbiased estimator means the estimator's mean must be equal to the actual variance, right? Actual value you are estimating. What you are estimating over here? You are estimating this, right? So and S is being used to estimate the variance. On expectation, they should be equal. So let us see, are they equal or not?
Sorry to interrupt. What is the quantity S? Can you say?
Yes, I have defined, it's a sample covariance, right? Sample variance. X, expected value of X minus mu X whole square. Yes or no?
Okay,
Variance formula key. Expected value of X minus mu whole square, right?
but you took the summation. Okay, for finite.
Finite, yes. In this case, you take an integral, right? Integral. And since they're IIDs, each of them will be equal weightage, right? So you sample covariance, right? It's a sample variance, yes or no?
Yes, understood.
In real life, you know only samples, and if you have to find the variance of the samples, you will just take sample wise. All of them take the average. I guess you understood. Good. So now help me to do this. Is biased. Quickly we'll do this and stop for today. Tell me how to do this. This is very interesting. Please follow. And you will see in books, they will give you the formula, but never tell you. In YouTube videos also, you will not get. So please follow this. This is not
We'll
easily
break
given.
up the square.
Good. No need to break up the square. You have first, what will you do? Linearity
First,
of expectation.
take out n.
Take out n, take out the summation.
Yes. Yes.
So I will get expected value of x1 minus mu n cap whole square. If you have understood, not understood. IID and linearity. N is there, so I'll get n into n, 1 by n. Which is equal to 1, right? We will get only one term remaining, right? Ask me if you have a doubt. Then next step would be, tell me the value of mu n cap. This is also a random variable. Tell me, what is the value? We have defined sample mean, right?
Xi. 1 by n summation xi.
Very good. You are following. So what will you have now? 1 by n squared, expected value of summation of I equal to 1 to n x1 minus xi. Yes or no? Whole squared. Is this right?
বুঝতে পারলাম না এটা।
আরে LCM বুঝতে না পারার কি আছে? n x1 minus summation of I equal to 1 to n xi.
হ্যাঁ, by n.
হ্যাঁ, তো এটার হোল স্কয়ার উপরেরটা by n square, ঠিক আছে?
হ্যাঁ হ্যাঁ হ্যাঁ।
So n times I'm writing, instead of writing n times, I'm going to write x1 minus xi.
ও আচ্ছা, হ্যাঁ, ফাইন, ঠিক আছে।
Which is also equal to 1 by n squared, expected value of x1 minus xj, let us write j or I, from I equal to 2 to n. Yes or no?
আচ্ছা, ওটা তুমি x1 কেন লিখলে গো হঠাৎ করে? I didn't follow up. মানে
IID.
ও আচ্ছা, মানে দাঁড়াও, মানে since they are identically distributed, so আচ্ছা, any of the xi can be represented by only one of the xi. আচ্ছা, ঠিক আছে।
So 2 to n, 1 will be cancelled to 0. Easily understandable. So now do the summation, expand the square. What will you get? N times x1 minus xi squared. Yes or no? Plus n minus 1 into n minus 2 x1 minus, you can even write x2 squared. Ask if you are doubt.
মানে ওই I equals to 2 থেকে করলে কেন?
What is I equal to 1?
So x1
x1 minus x1, what is x1 minus x1?
কি আরেকবার বলো?
What is x1 minus x1?
0? ও আচ্ছা, হ্যাঁ ঠিক আছে।
So next, so this is okay. Next step. There are n minus 1 terms, right, inside? So what is the square of n minus 1? So x1 plus x2 dot x n minus 1 whole square. What is it?
একটা স্কোয়ার তারপর দুটো দুটো করে নেব।
Yes. So I equal to 1 to n minus 1 xi square plus 2 into I not equal to j or I greater than equal to j xi xj, right? দুটো থাকলে x1 square plus x2 square plus 2xy. The ছোটবেলার formula, right? Same thing I've written or not here? And now tell me, why is this? If I take expectation, I should have written a step like this in between. If I take expectation, what will happen? I am representing each of these as small xi. Okay. If I take expectation, what will happen by IID?
মৈনাকদা,
All.
that part না where you did that x1 minus xi ওটাকে I equals to 2 থেকে করলে ওটা তো ক্লিয়ার হলো, কিন্তু মানে তার পরে ওটাকে কি করে ব্রেক করলে ওভাবে?
This you are asking, this x plus x summation of 1 to n square of that.
না না, ওই যে ওটা n minus 1 x1 minus
ওটা
x2
এখনো
whole
ওটাই
square।
দেখাচ্ছি কি করে হলো, ওটাই কি করে দেখাচ্ছি, এটা তো জানিস। This one,
হ্যাঁ সবকটা স্কোয়ার, হ্যাঁ
this line.
yes yes।
So by linearity, what will you get? First term, linearity. N minus 1 terms are there or not?
Yes, yes.
What is the issue here? I cannot understand. Linearity you cannot use. Partho,
yes,
I have
we can
just
use
taken,
linearity।
I have x plus y plus z. If you have any doubt, just take a square of this and take expectation on both sides. You will understand. X plus y plus z square.
হ্যাঁ আরেকটা জিনিস, সিন্স দেয়ার ILT এই জন্য we can add n minus 1 into e of x1 square তো?
Yes, IID always IID matlab take x1 plus 2 into how many terms are there? N minus 1 into n minus 2, n choose 2 into 2, right? How many terms will you have? Two terms.
2 into n choose 2 নাকি?
2 into n choose 2 by linearity again. Expected value of xi into expected value of xj by independence, right?
ও হ্যাঁ ঠিক।
This is what I have written. Okay. Understood? Clear? So you have n squared, expected value of x1 minus x2 squared whole square plus n minus 2 into expected value of x1 minus x2 into x1 minus x3. Okay, by IID. Is it clear now?
ওই 3 অবধি কেন নিলে?
Two terms are there, na?
আমি না বুঝতে পারছি না এই জায়গাটা, মানে x1 minus x2 টা কেন নিচ্ছ তুমি?
Let me take ij. Okay, let me take ij. In this you understood xi xj.
হ্যাঁ, x x বুঝতে পেরেছি।
তো xi x এর জায়গায় আমি x1 x2 লিখতে পারি না? Any two terms. I can take x1 minus x3, x1 minus x5 also. What are the terms? x1 minus xi, right?
মাইনাসটা কেন নিচ্ছে?
What are the individual xi's? Do the algebra, man. This is algebra only.
xi's are x1 minus xi.
x1 minus xi, they're the individual terms. The sum of those is whole squared.
ও আচ্ছা, I took x2 and x3. আচ্ছা, ঠিক
The
আছে।
first and the second term I took x2 and x3. Because all terms
yes.
x1, x2, x2, x1, x3, x1, x2, x1, x4 are same.
Yes.
Okay. So this one will turn out to be x1 squared plus x2 squared minus 2 into x1, x2, then plus n minus 2 x1 squared, then x1 x3 minus expected value x1 expected value of x2. Yes or no? Okay. Again, I have expanded only, nothing I have done extra.
Like x2 আর x1 টা ক্যান্সেল হয়ে গেল, মাইনাস x2 প্লাস
হ্যাঁ,
x1।
এটার
আচ্ছা,
কথা জিজ্ঞেস করছিস তো? এটার কথা?
হ্যাঁ 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 হ্যাঁ,
এটা হচ্ছে x1 x3 plus x2 x3 minus x2 x1. একটু অ্যালজেব্রা না করলে এগুলো তো, this is not supposed to be done at this level. x2
মানে এরপর আইআইডি বলে x2 x3
Yes.
ম্যাটার করছে না, সেই জন্য। আচ্ছা আচ্ছা,
Yes.
বুঝেছি।
correct. Good. Then what will you get? These are, what are these terms? Expected value of x1 squared. This is again what? Expected value of x1 squared minus. So again, I can take linearity, right? Yes or no? x1 and x2 are still the same thing again. Yes or no?
Yes, yes.
So this will become 2 into expected value of x1 squared minus expected value of x1 whole square plus n minus 2 into expected value of x1 squared minus expected value of x whole square, right? IID. These two are the same again. Same.
Yes, yes.
So what will I get? 2 into, so n into variance of x1, right? I'll get, বুঝতে পারছিস কি বল? I think it's okay, right?
Yes,
This is
yes.
n my, right? So this is what I got at expected value of unbiased estimator, is unbiased. Okay. So is this equal to what I needed? Partho, is it okay? If it is not,
Yes, it's okay.
please do the math. It is not, it is just algebra. There's nothing, no concepts over here. And I have gone very slow. So see, the expected value of this is n minus 1 by n into variance of xi, right? Which is equal to sigma squared. Now you tell me, is it giving me a biased estimator or unbiased estimator? Is it giving me sigma squared?
Only a little biased.
Little biased. Little biased towards samples. How can I correct it? Can you help me? How can I correct it? Just multiply and divide. This is what you will do in your t-test, which is also there in your syllabus. And everywhere you do, you apply sample covariance. You will do this. So is this biased or unbiased?
This is
It's
unbiased.
This is unbiased.
So, good. I have written again unbiased everywhere. So this should be biased. Biased. So unbiased is equal to n into n minus 1 S bias square. What was the value of S bias square? Uthrij? 1 by n summation of xi minus
Mu n cap.
Mu n cap squared I equal to 1 to n. So into n by n minus 1. So this is why in books you will be seeing defined as sample covariance. Sample. Unbiased. As n tends to infinity, it does not matter, but in real life you will have maybe 50 samples. In that case, it will matter. Which will become equal to 1 by n minus 1 square root of I equal to 1 to n, right? I hope this gives you an understanding of how we are using statistics. With that, I'll stop recording. I'll ask anybody any questions. Any questions do you have? And I'll stop recording. And we'll begin with tests next day. Statistical tests. Okay. Since there's no more questions.
Dada, out of context, one question. Out of context means the email that you will teach after this, how much coding you will do, and definitely will do in Python, and how much prerequisite knowledge we need.
Nothing is required.
Python.
Nothing.
No, like packages, those things.
I will tell you, nothing is required. You will only be using NumPy for the tougher first, and then you can learn. Documentation is available online. Just search and learn. There's nothing to learn in Python. Python, we will just code and learn. There's nothing. So the homeworks I'm giving now, try to do that. For example, I gave today a homework sample from you, that distribution I gave you, isn't it?
Yes.
Try to do those. Okay, when you are able to do, yeah. I'll stop recording and then answer your questions. Yeah.